Hey guys, good morning all. Just give me a in the chat if you guys are able to hear me and see the sublime text. Quickly give me a in the chat if you guys can hear me and see the sublime text. All of you can. Cool. Alright guys, I think we've waited for enough time. Let's get started with the session. We are quite a bit delayed for today's session. Alright, let's have a quick revision what we have done in the last class, which was yesterday, and then we'll continue with today's session. So in last class, we started with backtracking. We sort of almost finished it. Just one last question that we have to complete, right in a maze, that will start for today. So today we'll be targeting to finish backtracking, and most likely we'll get started with the trees. There might be one or two doubt question we can pick up, but most likely we'll get started with the trees. The retina maze is going to be 8 questions, 1 variation, and then one base question, and then 7 variations. Okay. All right. Let's quickly revise what we have done in the last class. We start with backtracking as a topic. Backtracking is an optimization of a recursion without storing the state results. In dynamic programming, we store the state results. Backtracking has nothing to do with storing the state results. So how it is actually optimization of recursion? It's optimization of recursion because we are looking to exhaust all the possible states. Just like in DPI, I gave you a template for 4 steps. In backtracking, we have a template for 2 steps. Simple 2 steps. Number 1 is identify whether the question is actually a backtracking question. And number 2, once you've identified the question is a backtracking question, that is when you start implementing backtracking. Number 1, how do you identify it's a backtracking question? You look for the keyword, and the keyword itself will tell you whether it can be solved by backtracking or not. Now again, here's a caveat. Do not unnecessarily try to make a question as a backtracking problem, because backtracking problem very clearly will indicate that it is asking you to exhaust all the possible problems. How do you understand exhausting all possible state? You will read the question like check if, is it possible, whether it can be done, so on and so forth. Sometimes these keywords will be very explicit in the question. Sometimes you have to read the question and actually understand the content and intent of question. Okay. Most likely the output will be a true or false, but not always need to be. It's a binary solution, true, false, yes, no, possible, not possible. Let's see how we can implement it. A very common backtracking problem is n queens problem. So the question statement start like this. Can you place n queens in a chessboard? Now queens has a rule in chess is that you cannot put them in the same row, same column. Even if you have solved this problem statement or not, even if you look at the keyword, can you place? That gives you an indication. It is asking me to exhaust all possibilities in 8 cross 8 or n cross n chessboard. Then I can make a decision whether I can or whether I cannot. So wherever the intuition is exhaust all the possible state, that's a backtracking question. Okay. And if you just Google it, n queens backtracking solution, you'll find all the articles. Second is retina maze. That's the problem we are going to solve as well. So what is the statement? There is given a source, there is given a destination, there is given some directions in which you can travel. The language of the question starts, can the rat reach to destination? So when you read the word can the rat, that gives me possibility. I have to explore all the possibilities, then come to conclusion. Again, the underlying algorithm is backtracking. Now, once you identify the question can be solved by backtracking, that is when you move to step number 2, where you know how to apply backtracking. Now, in terms of apply backtracking, you need to be clear with one thing. In dynamic programming, we work with the states. In backtracking, we work with the choices. What do you mean by work with choices? In backtracking, there is only 2 choices. Either you include or you exclude. So if you include it, my current sum will update to current sum plus new number in your combination, and my target will reduce to target minus current sum. If you choose to exclude it, then my current sum would remain same and my target would remain same. Okay. These are the list of questions that we have to implement. We have solved 2 questions in the last class. We'll be starting with the third and the final question today. Question number 1, I've added a lot of V's here because it's a very, very important question, which has been asked in Amazon, Google, Cisco, Apple, and multiple other companies. This is the problem that you're seeing on the screen is the exact question which was asked in online assessment, but its variation has been asked in multiple other companies, farm companies. This is called subset sum problem in general. What the question says is you're given an array. In that array, you're given a target. If you're able to take subset sum, any of those values, if you're able to get the sum, you return true, otherwise you return false. Okay. Now we're going to apply our template, sort of template that we have built. Step number 1 of the template is to identify. So if you look at the problem statement, when you read the statement, it says you have to return a Boolean value of true if the goal can be reached or not. The moment I read the word if the goal can be reached means I need to explore all those possibilities, whether it can be done or not. Okay, that gives me a clear indication it's a backtracking based question. That is hint number 1. Hint number 2, this statement in the question which says if there are hens, which sum give the exact goal required. That's also a very clear indication it's a backtracking based question. So step number 1 is sorted. If you read it in 5 seconds, you'll get to know it's a backtracking based question. Now the second part is how exactly do you apply backtracking? So same logic, you're going to include current sum and target will change. You're going to exclude current sum and target will remain the same. So we are going to build cases here. If my target becomes 0, means I'm able to found a combination, I'll return true. Remember, in this question, I'm not asked to print all the combination. I'm asked whether a combination is possible or not. Even if there is one combination, return true, otherwise return false. If I go index out of bound, I'll return false. If my target becomes negative, means my current sum has become greater than target. It's an invalid combination, return false. Otherwise, once we clear off these 3 base cases, then we move to the 4th condition, which is 2 possibilities. Either I'm going to include a number or I'm going to exclude a number. If I include a number, I'll move to the next value. My target will reduce to target minus area of index. If I exclude a number, I'll still move on to the next value, but my target would remain the same. We wrote down a code, we write multiple 4-5 test cases, 4 test cases to verify it. Okay. So these are the two conditions which we talked about, base conditions, and then we talked about include or exclude. The most important line in this code is line number 307. When I'm returning my answer, I'm not returning include, I'm not returning exclude, I'm returning include or exclude. Why did I use the word or here? Because if you understand the tree diagram of it, what exactly is happening in recursion here? At every state, you're making two choices. What happens if I include it? What happens if I exclude it? So if we start with 2, and if I go to 4, I have two choices. Either I can include 4 or I can exclude 4. If I include 4, 2 plus 4 will become 6. If I exclude, 2 will remain 2. Same at 6, the next number is 8. I have two choices. 6 plus 8, 14. Or if I don't exclude 8, then will remain the 6. So on and so forth. So with that logic, at every moment, I'll be making two choices. That recursion will span around 2 raised to the power and branches raised to the power depth. Okay. And that is why whatever number that you're searching, that can only be made in the leaf nodes that we have here. All the node values that we have in the leaf nodes. So that being said, you will be able to find out whether you can make a sum or not make a sum. So you need a combination either by including or by excluding. So what you will do is return include or exclude rather than returning either include or exclude. Okay. Time complexity 2 raised to the power n, space comp to big of n, as we discussed, pass all test cases. Next question is a tricky question, combination sum, which has been asked in Facebook and many other companies. The language of the question is the most critical part here. The question itself it's tagged as a hard level question, but if you try go with the implementation, it's medium to hard. But if you look at the problem statement of the question, it's definitely super hard. Okay. What I have seen as a candidate, what I have seen as an interviewer, a lot of people just struggle to identify what exactly needs to be done here. So simple trick for that is when you read such kind of a problem, and there is possibility you'll find such kind of problems in online assessment, not exactly in interview. The easiest way to do is divide and conquer. So you start writing down all the conditions one by one and then try to backtrack what sort of data structures, algorithms I can use to solve those conditions. So to make this question crystal clear to you, I divided these 5 conditions line by line. We go word by word and we understood. First thing first, my problem statement says I have to return a list of all unique combinations of array. Now, one combination is an array. When you say list of all unique combinations, you're talking about array of arrays or 2D array. So my final answer will contain vector of vectors, list of list, 2D array. So my combination will look like something like this, which will contain a 2D array where every element is going to be array itself. Next line. Elements in a combination must be in non-decreasing order. Means inside one combination, I will have the increasing order value. Straightforward. Combinations themselves must be sorted in ascending order. Now this is interesting one. Inside a combination, it should be ascending order. Between the combination, it has to be ascending order as well. What do we mean? I can compare between two values, which one is smaller, which one is greater, we can understand that. But how do you compare between two arrays, which one is smaller, which one is greater? So that logic they have given here. Combination A is greater than combination B if A1 is greater than B1 or A1 equal to B1 and A2 greater than B2 and so on and so forth. What does that mean? When you have to compare between two arrays, you look at the first element. If first element, whichever first element is smaller, that's a smaller combination. For example, if I talk about 1, 2, 3, 2, 3, 4, I'll compare between 1 and 2. 1 is smaller, so this combination becomes less than this. What happens in the edge cases where first element is same? Then you check the second element. First two elements are same, check for third element. Nth element is same, check for n plus 1th element. Okay, that's how they've given the logic. Next, solution set must not contain duplicate combination. So between two combinations, repetition is not allowed. Inside a combination, repetition is allowed. Okay. Once we are crystal clear with these conditions, that is when we move to the sample test case. And we try to understood why in sample test case, out of this 6 combination, we have only one combination in our final answer. Why? Because we need only the ascending order. And there will be only one ascending order apart from n factorial by r factorial combinations. Then we move to the solution part. We write down the code in Python, time constant to raise the power n, space comma to big of n, pass all test cases. Same question is present in lead code called lead code 39 combination sum. We write down the code there. We pass all the test cases. Okay. How do you write down the code? First thing first, since I want the output in a sorted array, what I'm going to do is before even I go to backtracking, I'm going to sort the array. If I sort the array initially before applying backtracking, I will get the sorted permutation. That solves my problem of sorting row wise or column wise. Number 2, it asks for unique values. So what I can do is I can create a set out of it. That will solve the problem of unique values. And third part is applying backtracking. So backtracking would contain conditions. If target becomes 0, combination found. In combination found, I don't have to return true or false. I have to add that to my answer and return list of combination. Case number 2, if target become negative, current sum will become greater than target. I can ignore that case. I will not add to my answer. Case number 3, if my target is positive, now what do I need to do? If my target is positive, I need to insert the present array and I need to backtrack. So my target would become target minus array of 5. If I don't select, target would remain the target. We write down the code in Python and Java, passed all the test cases, 2 raised to the power n, space bounty big of n. Okay. This is something that we have completed till the last class. Quickly give me clear. If everybody clear with the revision, any doubts, any questions, please let me know. Come on guys, quick in the chat. All clear? Cool. I saw one question. PDF on DP. PDF is incomplete. We have chapter 1 in PDF, which is already inaccessible to us. Okay. Chapter 2 to 4 are not accessible as we don't have premium. Okay, I'll look into it. The thing is that if I try to directly print it on the website, it does not allow me to take a PDF. It just comes as empty. So I have to take a screenshot of every single portion, and that's I have to convert to PDF. But okay, I'll do it, but I might not have time today to do it. But whenever I get time, I'll take those screenshots, convert into PDF and stuff. Okay. All right, guys. But I'm pretty sure somebody would have already uploaded on the GitHub. Just do a search on GitHub. You will probably find something. But if you don't, then okay, I'll spend time on that. Now let's move on to next question, which is question number 5 here. That is where we'll start. So that is going to be rat in a maze. We're going to talk about all variation. When I say all variation, there are going to be 8 variations. Okay. Let's talk about the problem. So what I'm going to do is I'm going to tell you about the problem statement, the way original version is asked, and then we'll move on to the variations of it. Okay. And this question itself will take us more than half over class time to complete all the 8 to 9 variations that we have. Okay. This is the problem statement. Check for possible path in a 2D matrix. Okay. The task is to check if there is a path from source to destination. Okay. So you will be given a source, you will be given a destination, you will be given a matrix. Your task is to check whether there is a path from source to destination. Your source will be top left, which is matrix 0, 0. Your destination is bottom right, which is matrix of m-1, n-1. Apart from that, an interesting change in the matrix, -1 is considered as a blockage. Okay, means you cannot go through that cell. So 0 is considered to be a safe cell. So wherever you find 0, you can go through it. Wherever you find -1, you cannot go through it. Okay, simple, can go through it. Now, one thing to understand here, if you're given some path in the matrix, 0 means you can go through it, -1 means you cannot go through it, source is 0, 0, destination is n-1, n-1. Basic variation we are solving, then we'll move on to extensive variations. Obviously, if your source contains -1 or your destination contains -1, output is always going to be false. Agree? If your source contains -1 or your destination contains -1, output will always remain -1, no matter whatever size of matrix and whatever matrix you provide. So it will be always mentioned in the question. Even if it is not mentioned in the question, use some common sense. Your source and destination will always be a safe cell. So safe cell means 0 in this case. Okay. So if I talk about directions, you can move in all 4 directions. Means from your current position, you can go to up, you can go to down, you can go to left, you can go to right. And in terms of constants which are given to you, since you are doing backtracking here, constant will not be that high. So it will start with something like this. 0 less than equal to I less than equal to whatever row. J would be representing between your column. Then you will not have an empty matrix because it starts from 1 less than equal to 1000. And your number of columns would also be equal to 1000. Okay. So let's start with test case number 1. So first test case, you guys let me know whether the output is supposed to be true or false. 0, 0. Let me make it here. -1, 0. -1, 0. -1, minus 1, 0, 0, minus 1, 0, minus 1, 0, 0, 0. This is my destination and this is my source. Let's make it here. Very good. All right, guys. Source is 0, comma 0. Destination is m minus 1, n minus 1. You guys tell me, based upon the current constant, provided you have to go from source to destination, you can travel in all four directions. Is it possible to reach from source to destination from the red? True or false? Cook in the chat, guys. What is the output is going to be? The output is going to be true. Why it is true? It's a pretty clear path here that you can see. I will just identify the path by writing M here. My mouse will come here. M represents the mouse here. Will come here, take a down, another take a down, and then we'll move on to the right to reach the destination point. Okay. Now, test case number 2. Let's talk about a second test case. I'll keep this guy same. Move the test case number 2. There you go. Now, what has changed in the test case number 2 is this guy becomes minus 1. If this is minus 1, now tell me the output, whether you can reach to the destination or you cannot reach the destination. The output will be false. Okay. If the output is false, this is the function that you have to complete. Boolean, which is can travel, and you're given an integer matrix. Okay. So if you look at this, I need to complete a function where I'm given a 2D matrix and I just need to return whether I can reach to the destination or not following the constraints. If I can, return true, otherwise return false. I'll take a pause here and I'll make sure that all of you guys are crystal clear with the problem. Then I'll give you guys time to start solving it. Any doubt in the problem statement? Anything which is not clear, please let me know. If the question is clear, type clear in the chat. Come on, guys, quick. All good? Everything is crystal clear? Can move in 4 directions. When you say any, it's important to specify it's not 8 direction, it's 4 direction. So up, down, left, and right. This is given here. Okay. Alrighty. If everything is clear, you guys know the drill. This is the function that you have to complete. Posting that in the chat. Feel free to code in any language of your choice. Please change your message directly to me. Do not message to everyone. Whenever you guys are done with your coding, do mention time and space complexity with the code. And whenever you guys are done, just let me know in the chat. We can discuss. Okay. That being said, your time starts now. Change your message directly to me. Do not message to everyone. All right, guys, enough time. Are we good to discuss? Do you guys need more time? Please let me know. Are you guys done with coding? Do you guys need more time? Can we discuss? Just let me know. 1 minute. Okay, just take 1 minute, guys, not more than that. And then we can start discussion. Quick in the chat. All right, 1 minute is over. Let's start the discussion now. Okay. Anybody who's able to complete the code? Yes, no, in the chat. Okay. Anybody who's facing any problem in solving the code or writing the code? Cool. Let's start with a very basic variation. There are many solutions or many ways that this question can be solved instead of saying using the word solution. Some people write it in DFS, some people write it in BFS, some people name it very different versions. I am going to write a code which is extensible enough. What do you mean by extensible enough? I want to write a code, or we want to write a code which do not just work for this version of the question. If anything changes, for example, if my source changes, if my destination changes, if my direction changes, or anything changes in general, our code should be extensible enough to accommodate those requirements. We want to write a code like this. Okay. How do we write that code? Build code there. Before that, we need to talk about the approach. And even before that, we need to revisit something which we discuss in our DP case, which is direction metrics. I hope you guys remember this name. I told you we'll be revisiting this direction matrix or direction mapping once we go to the backtracking. And now is the time to revisit it. Okay. What is the direction matrix for mapping and why it is important here is because we are traveling in a matrix and we're traveling in multiple directions, we do need to track the coordinates which happens after every turn. So let's say my current state is I comma j. Let's talk about what will be the new coordinate. If I take a right, if I take a left, if I take a up, if I take a down. If I take a right, my I comma j will turn to I comma j plus 1. If I take a left, my I comma j will turn to I comma j minus 1. If I take a up, my I comma j will turn to I minus 1 comma j. And if I take a down, my I comma j will change to I comma j plus 1. So I can write this as 0 comma plus 1, this as 0 comma minus 1, this as minus 1 comma 0, and this as 1 comma 0. Okay. Yeah, this would be I plus 1 comma 0. Okay. This is the kind of mapping we're trying to make. Why this is important? Once we'll go to the code, we'll make it clear. Okay. These are 4 directions. Now, the variation of this problem will also require you diagonal direction. So let's write it in advance. We will talk about the variations when we go there. But let's complete our direction mapping. Now, diagonal directions means 4 directions in diagonally, which is northwest, northeast, southwest, southeast. Northwest means up left, northeast means up right, southwest means down left, southeast means down right. Okay. So when you say up left, it's going to be I comma j, and it's going to turn to, if you take a up left, how do you find the new coordinates? You combine up and left. So if I take up, my I will become I minus 1. If I take a left, my j will become j minus 1. All agree? If I have to find the new coordinates for taking up left, what I'm going to do is I'm going to combine these two. What happens if I take up? What happens if I take left? If I take up, my row will decrease. If I take a left, my column will decrease. So my new mapping would be minus 1 comma minus 1. Easy. If you take a north right, again you're going to combine. Up means I minus 1, right means j plus 1. Mapping becomes minus 1 comma 1. Down right. Down right means I comma j. If I go down, I plus 1. If I go right, if I go left, it will be j minus 1. So mapping becomes 1 comma minus 1. And finally, if you take down right, so I plus 1, j plus 1, which is going to be 1 comma 1. Okay. Everybody crystal clear with this? Quick in the chat. Everybody crystal clear? Easy. Okay. Once we are done with our direction matrix mapping, now let's talk about the approach part, because we did not talk about how to solve this question exactly. And even before you go to the approach part, I'm going to make it with a real life example, so it becomes more intuitive to understand how will you solve it in a coding problem. A real life example is, let's take the real life example. Let's say here you are, okay, and there is some mountains that you need to hike for. And this is the path or valley wherever you have to hike for. And let's say the purpose of hiking is you have to reach a base camp here. Okay. Let's mark it as B, which is a base camp. Now, take it in a real life example. When you go for hiking and assume that you do not have any mobile, any GPS, any kind of location, there is no map with you. If you do not know where to go, that is exactly when it becomes backtracking. Agree? If you already know the path, it's not backtracking. Yes or no? Come on, guys, quick in the chat. You don't know which path, there can be multiple paths, and you don't know which path actually leads to us. So let's say there is path 1, there is path 2, there is path 3. There are multiple valleys, there are multiple mountains, there are multiple things that you have to traverse. You do not have a map, you do not have any GPS, you do not have any sort of navigation which can help you to reach your destination. So if you do not have any navigation, that is when you will be exploring all the path. Once you explore all the path, that is what we call as backtracking technically. Okay. Now, what happens here when you try to explore all the paths? Let's go one by one. What is going to be your approach to reach to the base camp? First thing first, you're going to start somewhere here. We call it as a source. And let's call this as a destination because that will be your destination. You will travel a path and you will realize it is not leading to destination. So you will mark this as cross. If you travel a path which is not leading to destination, will you travel it again? Come on, guys, quick in the chat. If it is not leading to destination, you will not travel it again. Second part, if you will not travel it again, how would you know that you have already traveled that path? Think in a real life example. How would you know? Most likely, let's say you encounter a tree, and from the tree that know that this path, from this tree, there is a path goes, which is not leading me to destination. So you are going to mark something. You're going to mark something so that you do not revisit that path. Agree? That's how you will do it in real life, provided you do not have any navigation. Okay. And once those paths which are not leading it, you will mark them, those paths you have already visited. Once you mark the path you have already visited, this will save you time to not visit them again. Correct? Then you will keep on exploring the path till the actual path which reaches to your destination. How you would know that you have reached your destination? Because now you will be at the base camp, or basically now your coordinates will be equal to destination coordinates. All agree? Easy? Okay. So a couple of things to point here. We start with the source. We explore the path. Every path we traveled, we mark them. The reason we mark them is we are not visiting it again. If it does not reach the destination, I don't need to travel it again. Any path which is leading to the destination, I will mark it because once I have reached the destination, how would I know? Because my current coordinates will become equal to destination coordinates. Everybody crystal clear with this part. Easy? Cool. If everything is clear, I'm removing this diagram. Let's come back here. So this is a hiking example we just talked about with storing paths and marking visited paths. What is the approach here? Approach is number one, you maintain a queue which stores my current cell, I comma j for path. Number two, you insert 0 comma 0. Why 0 comma 0? Because that is my source. Where do you insert is? You insert in your queue. Number three, you run a loop. Run a loop for what? You run a loop till your queue is empty. Okay. When a queue is empty means I'm going to check for all paths. The moment I'm going to check for all paths, that exactly is my backtracking. That is the third part where I'm checking all the possible paths and I will checking if I've reached the destination or not. While I'm exploring all the possible paths, I need to mark all cells traveled as visited. Okay. All the cells that I've traveled so far, I will mark the travel cell as visited. Why am I marking that as visited? Because the cells that I've already traversed, basically the path that I've already traversed, I do not want to revisit it again. And number five, if you reach to destination, how do you know if you have reached to destination? You know if you have reached to destination by comparing coordinates, current coordinates with the destination coordinates. If you reach destination, you return true, else you return false. Okay. Now we are going to move to the code part, and even before we are going to talk about the variations. Okay. Backtracking will always queue? No, nothing like that. See, In DFS, you don't use a queue because you're technically storing the state in recursion. In BFS, you store it. We are solving here by BFS, not necessarily by recursion specifically. Okay, we're not solving by DFS. We are not doing recursion. We are doing iteration here. That's why we are storing it in. That's why we are storing in a queue. Okay, so let's start with variation number one that we are solving now. Variation number one is my source is 0, 0, 0, 0. My destination is m minus 1, n minus 1. And my direction is 4 directions I'm allowed to travel. Okay. Now what do we do? Start with the code part. This code will take time, but let's write down it so we'll understand everything. And a method path exists. Okay. I'll be given a matrix. I will be given nothing else. For the first variation, this is sufficient enough. What do? We define a direction matrix. Let's define the direction matrix as all the 8 coordinates we talked about. So 0, 1, 0, minus 1, minus 1, 0, and 1, 0. These are the 4 directions. Now what next? I will define mark all of them as not visited. So false into max of n. Mark every state as not visited. Okay. I'm going to create a queue to store my path. So when I say n, let me just make sure everybody is crystal clear. N is m into n. Basically, I'm marking all cells as unvisited. None of the cell is visited by now. Okay. This is my queue. Purpose of queue: store the path. Storing path. What else? Q dot append. What I'm going to append? I'm going to append 0, 0, which is my source. Okay. What next? This is enough to get us started. We got the queue. We started our source. Now we're going to actually travel. So while my queue is not empty. So while length of queue is greater than 0, what do? First thing, you'll find your current pair. Means what is your current coordinate, which is going to be a pair, q0. So that will become my queue, which contains current pair, current coordinates. So current pair will be what? It will be I, j. Okay. And once you got the current pair, what do? First thing first, you do q dot pop. Take it out from the queue. Once you have taken it out from the queue, the first thing that you're going to do is the current cell that you have reached now, you're going to mark it as visited. So visited of current pair of 0, comma, current pair of 1, you're going to mark it as true. Okay. What is that? Visited of I, j is equal to true. Now what next? First thing that you're going to check is the current cell that I have stepped in now, either by taking left turn, right turn, up, down, whatever direction, is it my destination or not? Because if I reach to my destination, I don't need to travel further. Agree? At this moment, once you have stepped into a cell, the first thing that you do is you mark it as visited. The second thing you do is, instead of traveling from that cell, first confirm, have I reached my destination? If you have reached your destination, there is no reason to travel further. Agree? Come on, guys, look in the chat. Cool. So before even traveling, what I'm going to do is I'm going to check if current pair becomes equal to m minus 1, n minus 1. If it becomes equal to m minus 1, n minus 1, means I have already returned. So return true from here. What next? If I have not returned, means I go to line number 188. Then I'm going to check for all possible path. This is technically where my backtracking starts. So these were all base conditions so far. Okay. Backtracking actually starts. What is your current pair so far? Your current pair is I, j. Current pair 0 contains, take this part. Current pair 0 represents I, and current pair of 1 represents j here. Okay. So for I, in range of what? Length of direction matrix, what do I need to do? My row would become, yeah, we'll check it here. My row will become current pair of 0 plus what? Direction matrix of I comma 0. Okay. And my column will become what? My column will become current pair of 1 plus direction matrix of I comma 1. Okay. While you are traveling it, you also need to make sure that even during the travel, you are still well within the range of in the matrix. Basically, check for boundary conditions. So, boundary conditions. And there is one more thing that you need to check. What is that? When you're traversing in matrix, apart from boundary condition, there is one more important thing you need to check. Anybody? Visited, we already checked. Okay. Okay, let's say visited. What else? And visited, correct. Apart from boundary condition and check if it is visited or not, we also need to check it is a non-blockage cell. Basically, it's a safe cell or not. Okay. So what do you do? If my row, which row and column are my new coordinates, if my row is greater than 0 and my row is less than m, column is greater than 0 and column is less than n, that becomes my boundary condition. What else? Matrix of row comma column is not equal to -1 and visited of row comma column is false. Okay. All of these conditions are true. In that case, you put it in your queue dot append, which is what? Row comma column. Okay. If all these conditions are true, you get out of this condition. If you are not able to find anything, you return false here. If I reach in this part of the code outside the while loop, means reached here, outside while loop, means what has happened? I have exhausted all possibilities, and my path does not exist. Everybody is still clear with this. I have added comments wherever required, but I'll go through the code once again, and then I'm happy to discuss more things here. Okay, let's go one by one. What exactly we're trying to do here? And there's a reason I've written a code like this. There are other ways that you'll find majority of the codes written, but I'll tell you why I did not go with that approach. Because I want to make this code extensible. As many variations would come, this code template will be able to handle all the variations. Okay, but that being said, let's go one by one. What is we are trying to do? We're trying to check, we're given a matrix, we're given some constants. We need to check whether a path exists in that matrix or not. If it does, return true, doesn't exist, return false. So first thing first, I make a direction matrix. How do we make the direction matrix? I've explained it here. We talk the 4 directions, 0, 1, 0, -1, -1, 0, and 1, 0. Next, I mark all the cells, which is m cross n, all the cells in the matrix to be unvisited. I create a queue for storing the path, and first thing that I'm going to append in my path is 0, 0, which is a source where I start from. Now, if I start from here, while the length of queue is greater than 0, means till the part I have not exhausted all path, I'll start. I'll take the path of the current pair, which is my current coordinates I comma j. I will pop it from the queue so I can travel the next path. I will mark this current cell I comma j to be true. I will check first, before even I start the traversal, I'll first check the current coordinates, do they match the destination coordinate? If they match the destination coordinate, return true because I've reached to my destination. If it does not match till this part, that is when we actually start applying backtracking. What do you do in backtracking? You check for all possible paths. So for I in range of length direction, I in range of length direction means you're going to visit 4 directions from every cell. Agree? You're going to visit 4 directions in every cell. Yes or no? Correct. So if we're going to visit 4 directions in every cell, so that's how I'm going through the matrix. And now I'll get 4 coordinates, row comma column 4 times. Every column, every cell that I'm going to go now, I need to compare whether my boundary conditions are satisfied, the place is not already visited, boundary conditions and not already visited, and it is non-blocking cell. So I'll add this condition. If it matches this condition, then I will append it to my queue. If I get out of the while loop, means I've exhausted all the path, I'm still not able to reach to my destination, that is when you will return the false. Any doubt, any question in this piece of code, let me know. Quickly in the chat, guys. If it is clear, type clear in the chat. Come on, guys, be quick. It's a straightforward code. All good? Cool. Now, coming to the part when I said, why did we'll talk about time complexity. Why did I write the code like this? See, in many articles, in many solutions, you will see a code written like this, a brute force way, where you have to justify four directions. So you will see a function called backtrack, whether they're doing DFS or BFS. They will part coordinate like this, I comma j minus 1. They'll create a function, they'll pass the coordinates, and then they will call the function four times. I comma j minus 1, I comma j plus 1, I minus 1 comma j, I plus 1 comma j. I am 100% sure if you have seen any variation of this question, you would have seen a code like this. Yes or no? This is the most popular variation you will see in the code. If you have not seen it, maybe just when you start solving such kind of questions, LeetCode has few questions like that. Then, or other websites have questions like that also. You will see this piece of code more commonly. Okay. Now, there is a caveat here. What is the caveat here is, whenever you're calling this recursive function, at every recursive function, you will be exploring the four possibilities. So your time complexity will hit the part of 4 raised to the power n. And what is n here? N is m cross n, which is what? Total number of cells. Number one, extremely high time complexity. Number two, if my coordinate changes, if 4 directions are or more added or 2 directions are reduced, I would need to recur it again by calling it I plus 1, j minus 1, and so on and so forth. Okay. This is not an extensible code. It will work fine on this variation, but it is not an extensible code. The second way of doing thing is, the way that I've written here is, all you do here is, if you understand, I've written this piece of code. Let me take this out here. For I in range length of direction, I'm taking row comma column. So my row will become I plus 1 and column will become j. That represents I'm going down. And if my row becomes I minus 1, column remains j, means I'm going up. Okay. Now, my total time complexity is what? I'm only traveling in the length of direction. So it is big of length of direction. Now, how is this code more useful? Definitely much less than the time complexity. And number two, anything changes. Do I need to make any code change here? For example, if the direction changes, do I need to make any code change here? No, I would just make the code change here. Agree? Come on guys, quick in the chat. This sort of code is way more extensible to accommodate any variation which can come. Now, before I go to variations, the sort of variation which can exist is number one, if there are more directions or less directions. Number two, if the source changes. Number three, if the destination changes. There is fourth variation, which I will hold on once we reach there. You guys tell me which line number I need to check if there is a change in directions. Which line number I need to change when there is a change in directions. So instead of right and out or 4 directions, I will be given 8 directions or 2 directions. All agree? Any other line that I need to change? Apart from this, any other line that I need to change? No. That's the only line I need to change whenever there's a change in direction. Okay. Number two, what if there's a change in the source? If there's a change in the source, which line number we should change? Quick in the chat, guys. 175. Correct. That's the only line I need to change. Number three, if there's a change in the destination. 195. Why 195? 184 is fine, but I just want to know somebody who wrote 195. Okay, you corrected it. Cool. 184 is the only change. All the variations which can exist will roam around 3, apart from one extra variation, which we'll talk at the end. So this code is extensible enough. Direction change, update to one line of code. Source change, one line of code. Destination change, one line of code. That's it. This code will take care of all extensibility which can exist for this question. Okay. That being said, now let's move on to the variations part of it. Everybody crystal clear with variation number 1. Source is 0, 0, destination is m minus 1, n minus 1. One moment. and direction are 4 directions. Okay. Yeah, n is m into n here, right? I've already written is n is equal to m into n, mark all this as visited. So you can run a for loop, mark all of them as unvisited. Cool. All right. If variation 1 is clear, I thought somebody has a question. Okay, I'll share the Java code. I mean, it's pretty much the straightforward code, nothing too complicated here, but I'll write the Java code. Okay. Python code is easier to write, so I've written in Python, but we can code in Java too. We are using visited that saves us time, but in backtrack can we use extra states. In DP only we used to do that. In backtrack can we use extra state. What do you mean by extra state? You mean visited as extra state? Is that what you're referring? No, visited we are tracking because we do not want to repeat the path. That's the only thing we're keeping visited. Okay. So there is two ways generally that you can solve a question. It's not like every backtracking question needs to be solved by recursion only. You can do it in iteration, you can do it recursion. And I think that's the first thing which we talked about in recursion. Any piece of code you can write in iteration, you can write in recursion also. Okay. Even the tree question that we mostly will do by recursion, they can also be solved by iteration. It's just the code will become a bit longer. Okay. So here in this case, specifically, I take iteration because so far we have been coding only in recursion. So now you get more perspective how to understand iteration code. And number two, we have multiple variation of this question. I do not want to write a code which is specific to this variation. That's why I want to make it extensible code. Okay. Alrighty. How do we decide when to do iteration versus recursion, especially in complex case like this? Good question. See, a simple thumb rule is whatever you can do by iteration, you can do by recursion, and vice versa. A simple thumb rule is you try to analyze whether the problem will require me to go through the same route multiple times. If it will, easier is an easy choice there. Recursion is an easy choice there. If not, iteration is an easy choice. Example, in a tree question, when I am iterating over a tree, let's say binary tree, every node will contain the same structure. So it makes much more sense to do that code by recursion. You can do by iteration also. Nothing is wrong. You can keep a queue, you can try and store, and we can do everything. But the iteration code will become maybe 30, 40 lines of code. Recursion code will be 5 lines of code. So in those cases, we prefer recursion. In the cases where I have to go to multiple variations, make it more extensible, I would prefer the iteration code. Okay. Alrighty. What if we need to return all paths from source destination? Good question. If I have to return all the paths, what do I need to do? If I have to return all the paths, what do I need to do? Print whatever you're storing in the queue, that will give an answer. Okay. Alrighty. Cool. That being said, let's move on to variation number 2. Variation number 1 is already done. Let's make variation number 2. I'll just copy this guy, save me time. Variation number 2 is your source is 0, 0. Now your destination is x, y. And directions are 4 directions. X, y means my source is constant, which is 0, 0 in all the test cases. My destination is varying as per the test case. So with every test case, you will have a different destination. Okay. So what does that mean? My function will contain two more parameters here, x, y. So let's understand this with the test case. So we are crystal clear with the understanding of variation number 2. Okay. So let's make variation number 2 real quick. I'll take this guy. I'll come here. Let's call it as test case number 3, which is corresponding to variation number 2. Matrix is what? 0, 0, minus 1, 0, minus 1, 0. This let's make it as 0 instead of minus 1. And this time I want to choose this as a destination. Okay. And this guy is 0. If my source is 0, 0, my destination will be x, y. And let's say for this test case, x is 2, y is 2. So 2, 2, 0 based indexing. Now you need to tell me whether it is possible to reach from source to destination. Quickly in the chat. It's possible? Yes, you can come here, take a down, then move to right here. Easy. So let me true. Okay. Let's copy this guy, test case number 3, test case number 4, which is again a variation of version 2. Now this time I try to choose my destination here. And let's say this guy is now -1. And this guy also -1. So now my x comma y is 2 comma 3. Now you guys tell me, is it possible to go from source to destination? This column, which is third column, which is column number 2 in zero-based indexing, all the values are -1, means you cannot go past it. So output will be what? Output will be false. This is what variation number 2 is. Means your source is always constant, but your destination is always varying. So if your destination is always varying, means with every test case, you will be given x comma y, which is your destination. Variation 2, crystal clear to all. Variation 2, crystal clear to all. Okay. If you are crystal clear, look at the code, tell me the line number, what code will you change, what exact will be the code change, quick in the chat. What line number would change, what would be the code change so that it can be extended to variation 2. Guys, line number and the code change. Line number and the code change. Correct. Only thing that I need to do is, since only the destination has changed, all I have to do is, here I'm checking the destination. I should have made a comment here. Check if destination is reached or not. Okay. Only thing that I would do here is I would replace this with x comma y. So if this get replaced with x comma y, I can return true. Okay. Easy. Nothing else required. Let's move on to third variation, variation number 3. We'll take this. Let's move on to variation number 3. This is number 3, variation number 3. Variation number 3 is source is 0, 0, right? And your destination is x comma y. Now you're given two directions. Two direction means now you can only take a right or you can take a down. Now you guys tell me what will be the code changes, which line number, what will be the code changes. Quick in the chat. Line number, code changes. Correct. Now if it is only right comma down, so in terms of right comma down, what you're gonna do? You're gonna keep 0, 1 and 1, 0. Okay, that's simple as that. Okay. All right. If that is good, let's move on to variation number 4. Are you finding this template code easy? Because you just need to make one line of code change. Yes or no? If I've coded this version, you will have a really hard time making a code which is extensible enough for all variations. But you will see this code, how useful it is once we cover all the variations. There's a reason I wrote the code in the way that I've written. Okay. Let me move to variation number 4. So variation number 4, my source is now changing. Source is c comma d, destination is x comma y, and directions are 4 directions. When you say source is c comma d, means now I'm given 2 more parameters in my function. With every test case, I will have varying source, I will have varying destination for each test case. Now, what do you mean by varying source and varying destination? Let's understand this with an example. So we are crystal clear with it. Okay. So let's go ahead with variation number 4. This was variation number 2, test case number 4. This is test case number 5, which is going to be variation number 4. Okay. So what is happening here? You need the matrix. Your source is given as c comma d. And let's say for this particular test case, c equal to 0, d equal to 3. I want this guy to be the source. Okay. And destination, I can make maybe this guy as destination. Okay. Remove this. This is fine. I need some place to go, so I'll make this a 0. Okay. Now, with that input, can you go from source to destination? Yes or no? Source is given 0, 3. Destination is given 2 comma 1. Can you go to it? The output is yes, you can. Okay. Take a left, go down, that's it. Okay. Source will be varying, destination will vary with every test case. That being said, look at the code, tell me the line number, tell me the code changes. Quick in the chat, guys. Tell me the line number, tell me the code changes. Correct. Line number 246, instead of appending this, I will be doing C comma D, which is my source. Okay. I can comment this guy. I can say that q dot append 0 comma 0 is for v1 and v1 only. What else? This was 4 part of 4 variations we talked about. Now number 5 is v5. v5, let's keep it same. Move here, move here. Now this time what happens is your direction becomes a direction. Your source is varying, destination is varying, direction become 8 directions. Look at which line number, what's the code change, answer in the chat. Which line number, what's the code change? Correct. In 242, where the direction matrix is being defined, now I need to add 4 more directions. How would I do that? -1 comma -1, -1 comma 1, 1 comma -1, and 1 comma 1. This is how it would be. Okay. This guy here, all good. These are the 5 variations which are the most popularly asked 5 variations. More or less, 90% of the question that you will see for retina maze, they will be revolving around those 5 variations. And all of these variations become crystal clear and super easy if we go ahead with a template like this. Everybody crystal clear with it. Okay. If all good, anybody, any doubts, any questions? Cool. These are easy to medium level. I wouldn't say easy, medium level questions. Okay. If you make really complicated, it becomes hard level questions, until like this. Source is sharing, destination sharing, 8 directions. Now we are going to talk about last 2 variations, which is the most super hard version of it. Okay. What do you mean a super hard version of it? We'll see the constraints which will change, not related to source, not related to destination, not related to directions. Okay. So let's have a look at last 2 variations. Variation number 6 has been asked in Google. Variation number 7 has not been asked in any company, but it has a very high chances of being asked in a company like Google or Facebook or similar sorts. Okay. So if I talk about V6, in my V6, source is varying, destination is varying, and there are total 8 directions. Only constraint which Google added was you can take exactly case steps at a time. What do you mean by exactly case step at a time? Let's understand that with test cases. Okay, that's the variation which was asked to Google. Let's talk about exactly case steps first. How many test cases we have? Test case number 5, correct? So let's make test case number 6. Make it as V6, which is variation 6. And let's see what we are trying to do here. You have this matrix. Let's say your source is, let's make it simple, 0, 0, 0, 0. I'll make this as destination. So let's say 2, 2. Okay. And what else? What else? What else? 2, 2 would be this one. 0, make the destination. Okay. And this guy. Cool. What you need to do is you're given one more parameter, which is k. Exactly k steps. So if I'm given k is equal to 2 steps here, means I am going to jump 2 steps, jump 2 steps at once. Okay. Whatever direction is given, right, left, up, down, I can move two steps at once. What does that mean? A lot of people has a confusion in it. Let me clear it. When you say you can move k steps or two steps k equal to 2 for here is if my current cell is this, if I take two step directly and move to right, I will step into this part. I will not take one plus one step. I will directly take k step at a time. This part clear? Repeating myself. When the question is about exactly k step at a time, that does not mean you will take one step and then the second step. You will directly take a jump by two steps. Okay. Similarly, if you go down, I don't need to step in the minus one because I'm not taking one plus one. I'm directly taking the two step here to this guy, which is here. Everybody clear with this? Quick in the chat, guys. Shouldn't take this much long. Easy? Okay. This is what the variation is. Now you guys tell me, based upon this variation or this constant, the output will be true or the output will be false. The output will be true here. How I can come? There are two ways. One way, I can take a right and then I can take a down. Other, I can take a down and then I can take a right. Okay. That is test case number 6. Now moving to test case number 7, which is again V6. Test case number 7, let's try to, in this case, yeah, diagonal is also possible. In this case, 4 directions were given. That's why we said it. Okay. If it is 8 direction, then yes, direction is also possible. Here I mentioned the constant for 4. That's why I written 2 points. Okay. Now let's make another variation, V6. Source is this fine. Let's make this guy as destination. This main 0, -1, you reach here, all of this. What else? Can you reach anything here? Okay. K equal to 2 steps. Source remain this. Destination has changed to y equal to 3. Now you guys tell me, can you move from source to destination now? Quick in the chat. The output is what? Can you reach the destination from now if you jump 2 steps at a time? I get all the no's, but I get one yes. Why one yes? All others are saying no. There is one yes that I got. If there is one yes, what is the path? Quick in the chat, guys. We have more questions to solve. Okay. The answer is you cannot. That's why the output becomes false here. You will not be able to reach to this destination. Why? You take 2 steps, move to here, go to down, but you will not be able to come here because you can't take 1 step. Again, you go here, take a right, but you will not be able to come here. You cannot take 1 step. That is what the problem statement is. Everybody crystal clear with variation number 6. Source is varying, destination is varying, k is given. So now your function will contain a k, which means you can take exactly k steps at a time. Everybody crystal clear with the requirement. That is what was asked in Google. Okay. If you guys are crystal clear, take your time, look at the code. It will need some time because I want everybody to think and come up with an answer. Once you guys are ready, let me know. Which line number, what code change will you make? Change your message directly to me. Do not message to everyone. Let everyone think through. If the same question is asked in a Google, they're giving a Google interview. Which line number, what code changes you will make? Again, I'm repeating, do not message to everyone. Let everyone think through. Whenever you guys are done or ready to discuss, we will discuss. Okay. Your time starts now, guys. Update me in the chat whenever you are done. All guys, time check. Anybody needs more time? Are we good to discuss? Quick in the chat. Anybody needs more time? Are we good to discuss? Quick, guys, we have to start with trees. Don't want to take too much time on this. And we have one more variation after it. So be quick in the chat. Are we good to discuss? Anyone need more time? Please let me know. You can message to everyone now. We can discuss. Cool. Let's start the discussion now. See, guys, I see some of the people writing a variation multiplied by 2. K is not always equal to 2. I've just given example k equal to 2. K will be a generic number. So do not hard code the value for k equal to 2. Write your code which is generic enough for any k. Okay, part number one. Part number two, there is two ways we can solve this problem. What are the two ways? Where exactly I'm taking the steps. The moment you understand where exactly you're taking the steps, you understand the problem, right? I'm taking two steps or one step at a right based upon this direction matrix. Agree? Line number 308. That is where I'm taking, whether I'm taking a right, down, up, left at one step at a time. All agree? Yes or no? Okay. So one way of it is I can make it 0, comma k, 0, comma minus k, comma 0, k, comma 0, so on and so forth. This is one way of solving it, which all of you have given in the chat. All agree? Okay. This is fine. The code will work. Pass all the test cases, no worries. My personal preference, again, repeating my personal preference, my personal recommendation, do not change the direction matrix if the directions are not changed. In this question, directions are not changed. Only the steps are changed. So my personal preference, if you ask, I would say keep the direction matrix as a standard because it represents which directions I am moving, and change the part here because technically this is the part where you are taking steps, right? And considering with the code logic, you should make the changes wherever the source of the problem is. I can write this as 1 into direction of I comma j, 1 into direction of I comma 1 because you're taking one step here. If I have to take k steps, I will multiply here. Yes or no? Quick in the chat. Okay. Again, both are correct answer. It's my personal preference rather than changing the direction matrix where your directions are not changed. I would prefer to change it here because this is the part where we are actually taking the steps, k steps at a time. Okay. Alrighty. If this is good, this was variation number 6. Now we move on to variation number 7. Let's talk about variation number 7. Variation number 7 has not been asked in any company yet, but there's a very high possibility it can be asked in the top product based company. Let's take this guy, this guy, this guy. So variation number 7 is source is varying, destination is varying, directions are 8 directions, but now you can take maximum k steps at a time. Means you can take one step, two step, three step, four step, till k steps. So you can take maximum k steps at a time. Okay. So 1 till k, you can take any number of steps. You don't have to take exactly k steps, but between 1 to k, you can take any number of steps. So left, right, up, down, whatever you have to do, etc. Okay. Let's understand this with a test case. So it's still clear to everyone. So I'll take one more test case to verify that. Although I don't think I need to, but let's do it variation number 7. So everybody is crystal clear. If I take this test case number 7, let's make one more. Test case number 8, that will serve as my V7, variation number 7. Same thing, my k is equal to 2 steps, so I can jump at max 2 steps. Now what do you think will be the output? Quick in the chat. If I can jump at max 2 steps, what will be the output? Quick in the chat. All agree? Now the output is going to be true. Why? I'm free to take either one step or two steps. So if I take two step here, I can take two step here, I can come to one step here. Similarly, write down one step. Okay. Everybody is still clear with variation number 7. Anything you can take from 1 to k. Any number of steps between 1 to k. Maximum k steps. Anybody who's not clear, please call out. If you guys are clear, let me know. Come on, guys, quick in the chat. Variation number 7. Everybody crystal clear. Okay. If you guys are crystal clear, now let's move on to the solution part. Same thing. Look at the piece of code. Take your time. Do mention what line number, what code changes you will make. Let everybody think. Do not message to everyone. Let everybody come up with the solution and change a message directly to me. Once you guys are done, then you can message to everyone for discussion. Then we can go for discuss. Okay. Your time starts now. Think of all the edge cases before writing the answer. Your time starts now. Not guys, enough time. I think we should start a discussion unless anyone need more time. Are we good to discuss? Anyone need more time? Please call it out. We can discuss. All agree? Cool. So let's start the discussion. The question says you can take any number of steps between 1 to k, right? If you can take any number of steps into 1 to k, means it's a for loop or while loop, whatever that loop is. If I have to loop through it, this part where I'm taking exactly k steps at a time, if I just change it to by adding one more condition for j in range of 1 comma k plus 1 in Python, upper bound is the value that you've given minus 1. Now what I have to do? This guy will change, this guy will change. Now what I have to do is I just need to replace this guy with j. And now what it will go through is it will go through all the values from 1 to k. All agree with this line of code change? Yes or no? Easy. That's going to be our answer. Cool. With that being said, that marks the end of your backtracking. I'll share some sample questions to try out for, and probably would have got the assignment for DP yesterday. Today you should get for backtracking also. Okay. It is not better to run j from k and then decrease. J from k and then decrease. It's the same thing, right? What difference does it make? Either run from 1 to k or you came from k to 1. What difference does it make? Complexity is same and everything is same. There is maybe you're thinking that if I take k steps first, the chances are higher I can get that. That depends on test case to test case. Okay. We cannot generally say that if I take k step, the chances are higher. We saw in this test case, right? Also depends on the value of k, also depends what the variation in the matrix. Okay, cool. Alrighty, guys. Some questions to try out for. Let's talk about that and then we'll move on to next topic, which is trees. Rat in a maze, the question that we have just done, it may not be directly available on LeetCode as it is, but it's available on maybe GFG and other platforms. Okay. Connected islands is a very good problem, very identical problem, which is available on LeetCode. So if you want to try, one moment, guys. If you want to try, just go ahead on LeetCode. Rat in a maze, as it is available on HackerRank. If you want to try for it. Okay. Or I can just write here HackerRank. Cool. You can try out these questions. We can break if it goes to else, basically stop exploring for current K. One moment, let me answer that. And quiz can also solve using this approach. When you say this approach, you mean backtracking approach? Yes, not the same piece of code, of course. Okay. We can also break if it goes to else as basically stop exploring for current K. Which else condition? There is no else condition here. But do you want to reduce the operation whenever you get the answer you return to it? That we are already doing here. Addition to this if. Not exactly, because see, you have to travel for all that. Okay, I mean, you're talking about this else condition, right? If we include any else condition here. No, we don't need to return false from there and we do not need to stop here. By default, if there is no else condition, it will not even go there. It will not put it in the queue. But I have to explore all the possibilities wherever it is not -1 and 0. So let's say I go to a path, it is -1. That does not mean I return false from there. I will go to next path. If it is 0, I'll continue from there. That's why it is important. Okay. Alrighty, guys, this marks the end of our backtracking. I would just quickly revise it and then we'll move on to our next topic, which is a very important topic called trees. We have around 30 minutes, so we should be good to cover at least the theory part of it. Then we'll move to the coding part. Last question that we have solved, which is rat in a maze, all the variations. We talked about the basic variation. How does the rat in a maze look like? It's a 2D matrix. There's a source, there's a destination. There are some safe cell, there are some blockage cell, etc., etc. Okay. And further constants can be added. I'm given certain directions I can move, 4 directions up, down, left, and right. I'm given the constants of the matrix. Okay. Coming down here, first we talked about a real life example to understand how would you solve it. First, we talked about the direction matrix of mapping. We have listed down the direction matrix mapping. We tried to understand if I have to solve this question, let's track back it to a real life example. So in my real life example, I can take a hiking where I'll be storing the path, marking the visited cells, and then check if I've reached to destination or not. Okay. And if I convert that into a coding solution approach, my coding solution approach would be something like create a queue, store the current cell for the path, insert the source, run a loop till queue is empty, basically check for all path, mark the cells which you have traveled as visited, basically mark the path as visited. If you reach to destination, return tree, otherwise return false. Okay. So we told about 7 variations. First 5 variations are relatively medium level. 6 and 7 is a hard level variations. Okay. So we write down a code or a template which is capable enough to go extensible for any variation of this code. Okay. We talked about time and space comp. We talked about why we did not go with a recursive based code and why did we prefer the iteration based code. Okay. Alrighty, guys. If everything is good, now we can move to the next topic, another important topic, which is trees. I've given you some homework questions to try. Please do try it out. That will give you more confidence of solving questions like retinal base. Okay. There's one question I got in the chat before I start with the trees. I'll answer that question, then I'll start with trees. The question is how to think of doing this using while with queue. Initially, I couldn't think of it. Now it makes sense. Okay. How to think of it? Well, as I said, wherever you have to make a decision between iteration and recursion, think first before writing to the code. Think first, am I doing multiple repetitions of a same structure? If I am, go with recursion. If not, and their variations can exist, always write a iteration code. That is more extensible. That's the only answer that I can give you. Okay. And that's the only answer which makes sense. Okay. All right. If this is good, now we start with our second last topic of a data structure algorithm, which is trees. Another very important topic in terms of interview perspective and overall perspective. Can you document that here? Document, one moment, guys. Document what? One moment, guys. Document what exactly? Statement for statement reference letter. Which statement? Oh, okay. Recursion versus iteration. Cool. Recursion versus iteration. Let's write it down here. See, recursion, if it is similar structure, repeating multiple times, recursion is always a better choice. Example, trees. Again, I'm repeating, tree code also you can do by iteration, but we prefer to code by recursion because it's much shorter. Okay. Iteration, if extensible code and multiple variations. Okay. Example I just talked about, writing a message. As simple as. Cool. All right. Yeah, DFS happens with stack, which is recursion stack, and BFS happens with queue. Cool. Now let's go to the very important topic from online assessment as well as interview perspective, but in general real life example for software engineering role, which is trees. And then the last topic would be graphs. As I say, if you want to become a master in any data structure algorithm, just know 3 things about the data structure algorithm. What are the 3 things? What, why, and how? What is what, why, and how here? What means what is the use case that data structure algorithm is solving? What are its real life applications and how it is coded or implemented? Okay, cool. We'll try to answer this question for trees. Before that, we are going to understand something called linear data structures versus hierarchical data structure. So linear data structure and hierarchical data structure. You might have heard this term before, maybe in various other citations or sources. Linear data structures like arrays, linked list, stacks, and queues. Okay. Hierarchical data structure like trees and graphs. Okay. Have you heard this term linear data structure and hierarchical data structure before? You can just answer yes or no. Quick in the chat. A lot of you have heard it. Maybe some people are there who have not heard it. And if you have heard it, which is great. If you have not heard it, that is also fine. If you have already heard it, and I've given you the example which qualifies as linear data structure, which qualifies hierarchical data structure, Quickly tell me why they are called linear and why they're called hierarchical. Like what classify this one to be a linear data structure? What classify this one to be a hierarchical data structure? In the chat, 1 minute for you guys. You can message to everyone. Give me a crystal clear definition. No chat GPT or Google answer. Crystal clear, simple, plain English. What qualifies to say a linear data structure versus what qualifies to be a hierarchical data structure? 1 minute to everyone. Message is open to all. Quickly answer in the chat. Yes, when you give answer like this. We call it linear because, and when you say we call it hierarchical, because, just like this. Okay, complete in this format, which makes it crystal clear. All right, guys, message is open to all. Waiting for your answers. Once you guys are done, we'll start with the discussion. 1 minute on the clock. Cool guys, quick time check. Let's see what are the answers we have got in the chat. Guys, message to everyone. When I ask you to message to everyone, it's fine. Let's go step by step what we have. Breadth and depth are there for hierarchical data structure. For hierarchical, we have parent-child. Linear elements are in sequentially. Elements are in levels. Stored independent linear data structure, dependent and hierarchical. What is independent and dependent here? Sequential fashion, multiple layer, no parent-child relation, all elements are treated equal. Some kind of parent-child relation between the elements. Arranged in sequence, parent-child level-wise arrangement. It's in sequential manner. It's like tree, linear, cause, date stored in linear sequential. It's non-sequential. All values are the same level. Okay. Cool, guys. Let's decipher it in a very crisp format. First thing, I'm giving you two options, one and two. Tell me either it's one or two. The first one is elements are stored. By the way, none of the answer is correct. Elements are stored in contiguous location. That is why you call it as linear. And number two, there is more than one logical way of traversal. That is why you call it hierarchical. Out of one and two, which one do you think is the correct definition? Quick in the chat, guys. Out of one and two, which one you think is the correct answer? Both are wrong. Okay. Cool. The correct answer is two, which corresponds to the hierarchical part. Okay. First part, is incorrect. Why it is incorrect? Let's talk about it. Those multiple layers, the answer of multiple layers and all, it comes into place because you have more than one logical way of traversal. Let's understand it more. When you talk about linear data structure, for example, arrays, linked list, stacks, and queues. Okay. Understand the similarity here. If contiguous location was the correct one, linked list will not satisfy, stack will not satisfy, queue will not satisfy. So why is that they are called linear data structure? Because how do you traverse an array? You traverse in left to right or right to left, basically in a horizontal fashion. In a linked list, you travel from head to tail. In a stack, you travel from top to bottom. And in a queue, you travel from front to rear. All agree with this? In a linear data structure, there is a specific way you're going to traverse in those data structures. On the other hand, if I talk about hierarchical data structure, I have generally two ways or more than two ways. Beat my tree, beat my graph, beat one moment. That's a variation, right? Even in double linked list, you're traveling horizontally only. Head to tail, tail to head, however you're turning it, you're traveling horizontally. There is not more than one way of traversing. In a hierarchical data structure, however, what happens is, be it trees, be it graphs, be it any hierarchical data structure like articulation points or anything in general, there are at least two different ways. You can either travel by depth, which is depth first traversal, or you can travel by breadth, which is breadth first traversal. We'll talk about all of this in one by one. In the context of trees, there are three ways you can do DFS. You can do pre-order, you can do in order, you can do post order. In level order traversal or BFS, there is only one traversal, level order traversal. This part is still clear to all. Then I'll move on to number two. So the reason it's called linear data structure, because there is one logical way to traverse, then it is called linear data structure. If there is multiple ways or multiple logical ways to traverse, which leads to all the points which all of you have said, multiple levels, layers, etc., that makes it a hierarchical data structure. Everybody crystal clear with this? Cool. That was number one I wanted to clear. Number two, a lot of people confuse tree and a doubly linked list. So let me make this very clear. Tree and doubly linked list are very separate data structure. Doubly linked list means a node is connected with two different nodes. So B dot previous is equal to A and B dot next is equal to C. A dot next is equal to B. Okay. There is no hierarchy here. Every node is on the same level. Every node contains two pointers for sure, but those two pointers are on the same level. We do not call those two pointers as parent-child relationship. In my tree also we have two pointers, but those two pointers are on different levels or on different hierarchies. Here, there is no parent-child relationship per se, relationship, and all the nodes are on same level, same level. Okay. On the other hand, if you talk about trees, tree include parent-child relationship. And when you say parent-child relationship, there are nodes on multiple levels. So there is root, root has its child, children have their further subchildren. We don't use the word subchildren to be very honest, which is called root and child in general. But this is a differentiate. Child can have further child as well. Okay. So what is root here? Root is my topmost node. By the way, think of tree in a real life example and reverse the tree. That will make you understand the structure. Okay. So what do you mean by that? Let's say this is how a tree looks like in real life. I'm just trying to make it some kind of a tree. Okay. The tree will have roots here, 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 here. Okay. This is the real life tree. If you invert this is going to be a root. Let's call this as R. And then you're going to have your leaf. This becomes their children. And they can further have subchildren. Okay. So if you invert a real life tree, you will understand the structure of tree in the data structures. Everybody clear? This is your real life one. This is your data structure one. Just the inversion of it. Okay. And there's also a very popular question called invert a binary tree, which is technically converting it to here in the same format. Okay. Anyways, coming back here, moving here, let's come back. So what is root? Root is the topmost node. What is child? Immediate children under roots. And what is I'm referring to subchildren? Subchildren is usually not a word because we do not refer as subchildren. But just to make the distinction clear, child can further have children. That's what I'm calling as subchildren. So if we talk here, this is my A, this is my B, C. Let's make two children here, which is D and E. And this is F and G. Okay. So if I talk about root, what is the root? Root is A. If I talk about child, child is B and C. And what are my subchildren here? Quickly in the chat. What are my subchildren here? Correct. Subchildren become the children of child. So D, E, F, and G, etc. etc. How do you go from A to B? You say A dot left, you go to B. How do you go from A to C? You say A dot right equal to C. And this is where people confuse it. Few people confuse. I'm not saying everyone confuse it. A linked list, a double linked list also has two nodes, correct? Which contains next and previous. Tree also has two nodes which contains left and right, but there is a major difference between them. What's the major difference? Those left and right, they do not have any parent-child relationship. They are all on the same level. Okay. But in the context of trees, those left and right are talking about the parent-child relationship. Okay. So parent to child pointer exist. Answer is yes. Child to parent pointer. Is there a child to parent pointer? Yes or no? I can go from parent to child. I can say A dot left, go to B, A dot right, go to C. But can you go from C to A or B to A? The answer is no, you cannot. Why? Because imagine this. If I can go from A to B, which I'm able to, and I can go from B to A, it will mean my tree contains cycle. Yes or no? if I can go from parent to child and child to parent, that will mean my tree contains cycle. Now the question becomes, a good question becomes, can a tree contain cycle? If yes, good. If no, why not? What will happen if a tree contains cycle? 10 seconds, quick in the chat, message to everyone. Can a tree contain cycle? The answer is yes, all and good. If it does not contain a cycle, why it does not contain a cycle? What will happen if a tree contains cycle? Come on, guys, quick in the chat. Correct. The answer is, if a tree contains a cycle, it will become a graph. What do you mean by it will become a graph? Then there is no point of hierarchy. If I can go from A to B and I can go from B to A, there is no reason I should call B as a child. There is no purpose of calling B as a child because technically it will be just one vertex going to another vertex. There is no parent-child relationship here. Okay. So tree does not contain cycle. If tree contains cycle, technically you're solving a graph question, not a tree question. Okay. Alrighty, from the next class, we'll start with types of trees. We'll further deep dive into binary trees and ternary trees, so on and so forth. Binary trees, binary search trees, and ternary trees, so on and so forth. Okay. Alrighty, guys, let's start with a quick revision what you discussed as part of today's session. The good thing is we have started with trees. Next week, most likely your trees will be completed by the end of 2 sessions. May take one more class, and then we'll take 3 classes for graphs. So total 6 more classes are pending, which means 3 more weeks. Okay. All right, let's quickly revise what you've done as part of today's session, and then we'll close up the session. We solved a very good question, which is right in a maze and all the variations of it. We talked about, the question was talking about matrix is given, source is given, destination is given, directions are given, some blockage cell and non-blockage cells are given. Only thing that I need to do is go from source to destination, check whether it is possible to reach, return true, not possible to reach, return false. When the statement comes possible to reach, that itself tells you this is a backtracking question. Yes or no? The moment you read this keyword, check if it is possible, check there's a path exists, etc. That indicates it's a backtracking based question. Okay. Once we understood the problem statement, then we move on to the understanding and solution of it. First, we write down the real life example to understand, then we convert that into approach. We write down the directional matrix because it's going to be handy for us. We list down all the variation which can be asked for the question. We write down a code which is extensible enough for all variations of that problem statement. Okay. I told you the reason. Instead of writing recursive way, why did I write in an iterative way? Okay. We solved 7 variations of this question. First 5 are medium, 6th and 7th are hard level variations. Okay. Past all test cases, we talked about time and space complexity. These are the list of homework questions I have given to you. Let me share that here in the chat. You guys can try those questions for homework. And most likely, you will get your backpacking assignment by today. If you have not received it, please reach out to your course coordinator. He or she will be able to provide you assignments for backtracking and DP. Okay, DP, I believe you should have received by now. Then we talked about recursion versus iteration, what to use. We have documented that part for revision. We talked about trees in terms of 2 things. Understand the difference between a linear data structure versus hierarchical data structure. We talked about why it is called linear, because there's logically one way to traverse them. Why it is called hierarchical, because there's more than one logical way to traverse. Okay. Finally, we cleared the difference between tree versus doubly linked list. So we understood in doubly linked list, even though there are 2 pointers, previous and next, both the 2 pointers are on the same level. Okay. There is no hierarchy. There is no parent-child relationship. In the case of a tree, it has the 2 pointers, but they're pointing to the child here. There's a parent-child relationship left and right. Okay. We talked about root, child, subchildren, etc., etc. And then finally we talked about, can my tree contain cycle? The answer is no, because if a tree contains cycle, it will become a graph. Okay. Alrighty, guys. Everybody crystal clear with what we discussed as part of today's session? Any doubts, any questions, please let me know. If you guys are crystal clear, type clear in the chat. Okay. Everything is good. Let's wrap up the session here for today. DSA and articulation point, maybe we can take it as part of the doubt clearing session. It's not part of DSA as such. It's like competitive programming questions, but we have one doubt clearing session. If you want to cover a specific question, we can take it there. Okay, but not part of your DSA syllabus, just to be clear. Alrighty, guys, if everything is good, let's wrap up the session. Topological sort, Khan's algorithm, all of those, tries and all. Again, I can take it in doubt clearing session, but those are not part of DSA syllabus. Okay, if you want to cover tries, topological sort, we can. Okay, we have one doubt clearing session for it. We'll discuss once we reach to the end of DSA syllabus. Okay. Alrighty, guys. No more questions. Rest of these topics alone, we can discover them ourselves. Okay, we can document that once we reach to the end of syllabus. We still have at least 6 classes to complete our DSA syllabus first. Okay. All right, guys. Any more doubts, questions? All cool? If everything is good, let's wrap up the session here for today. Let's catch up in the next session, which will be next Saturday. We'll continue from there and starting with the topic of trees. Thanks for joining in. Have a good one. We'll see you in the next class.